Hello friends, so here is a question of grade 2017 civil engineering paper, and it's about the infiltration capacity, and it is based on the in the question it is given that it is based on Horton's experimental model. So it is given that the infiltration capacity, that is F is a function of C1 and C2, and this F is equal to C1 plus C2 e raised to minus kt. So that K is the decay rate constant and T is the time in hours, and C1 and C2 are the constant, and F is the infiltration capacity. It is given. It is based on Horton's experimental model. So during an experiment, the initial infiltration capacity was observed to be 200 mm per hour. It is the initial infiltration capacity. Okay. So after a long time, the infiltration capacity was reduced to 25 mm per hour, and the time is not a specific one, and it is given as long time. And if the infiltration capacity after 1 hour was 90 mm per hour, the value of decay rate constant, we have to find out the decay rate constant, that is K in hours inverse up to 2 decimal place. It is a 1 mark question. Okay, so that it is a numerical question, and you will get no negative marking for this. Okay, so we will look into the solution. So let's take the F, that F is equal to, it is given as C1 plus C2 e raised to minus kt. So the initial condition, what is the initial condition during an experiment? Initial infiltration. So at initial condition, it is given an initial infiltration capacity was observed to be 200 mm per hour. So F is equal to 200 mm per hour at what the value F is. So here you can see that F is a function of K and T. So F is equal to 200 mm at what? At T is equal to T is equal to, since it is an initial condition, the T will be equal to 0. So the starting condition, it is very important. This is the important part here. T is equal to 0. So here take decay rate constant as K, and if this K is not varying with time, this K is also taken as constant. Okay, so here decay rate constant K is as the name indicates, it is a constant value. Okay, so we will put this in the equation, that 200 is equal to C1 plus C2 into e raised to minus k into t minus k into 0, e raised to minus k into 0 is e raised to 0, that is C1 plus c e raised to 0 is 1, that is C1 plus C2. So we have the first equation, 200 is equal to C1 plus C2. So next it is given that after a long time the infiltration capacity was reduced to 25 mm per hour, long time. So F is reduced to 25 at T is equal to what? It is given after a long time, so we can take it as infinity. It is also important here. So put it in the equation, we will get 25 is equal to C1 plus C2 into e raised to minus k into infinity. So what will be this value? What will be this value? This value is C1 plus C2 into, what is that, e raised to minus this value is e raised to minus infinity. This e raised to minus k into infinity is e raised to minus infinity. Again this equal to C1 plus C2 into 1 by e raised to infinity. E raised to infinity is again, it is the value infinity. So we have 25 is equal to C1 plus C2 into, that is 1 by infinity. 1 by e raised to infinity is 1 by infinity. 1 by infinity is, it is equal to 0. 1 by infinity is equal to 0. Okay, so we will get C1 is equal to 25. This, put this in equation number 1. Put 2 in 1. We have 200 is equal to C1 is equal to 25 plus C2 implies C2 is equal to, implies C2, we will get the value of C2 as, we will get the values C2 is equal to 200 minus 25, that is 175. Now we got the value of C1 and C2. Okay, so next we have after 1 hour. So after 1 hour, the infiltration capacity is given as, after 1 hour, the infiltration capacity is given as 90, F is equal to 90 mm per hour after 1 hour. Okay, so put this in equation. So the T is equal to 1 hour. Okay, so put it in the equation. We will get 90 is equal to C1 plus, in the equation we will get 90 is equal to C1 plus C2 into e raised to minus k into T is equal to 1. Okay, so what is the value of C1? C1 we have already found out. It's 25 plus C2 is 175. 175 into e raised to minus k. E raised to minus k. So we will get 90 is equal to 25 plus 175 into e raised to minus k. You will get the value. We will do it in here. So we have 90 minus 25 is equal to 175 into e raised to minus k. 90 minus 25 is equal to 65 is equal to 175 into e raised to minus k. So 65 by 175 is equal to e raised to minus k. So take the natural log on the two sides. We have what? We have ln of 65 by 175 is equal to minus k into ln e, minus k into ln e. So what happened? This value is, you will get this as minus 0.99. This is equal to minus k into, what is the value of ln e? Natural log of the e is equal to 1. So minus 0.9 is equal to minus k. So what it means, it will give the answer as k, or decay constant, is equal to 0.99. And the actual answer, and in the answer key is 0.9821. If you get any value in between this, you will get the full mark. Okay, so we will see in the next problem. Okay, thank you.